Hello everyone. I hope you are doing well. Everybody can hear me and see my screen.
Yes,
Yes,
doctor.
doctor.
Thank you very much. So today, in the following of our session for the graduation project, because when I reviewed your proposal, I realized that most of the students wanted to work on the modeling part and also transportation model. So in this case, I decided to put some sessions for this topic. We will review together what was the modeling, formulation, basic fundamentals, principles, and after that we will go for transportation model. We will review, I will divide it to the two session. I will make it in a two part. First part, we will review these fundamentals for these two, modeling, formulation, and transportation model. And in the second hour, the second session, we will make it the same things in the software lingo. If you remember, we had it in our class sessions. We will how we apply these methods, methodologies inside the software, because when you graduated and when you want to go to works, no one asks you to solve anything by your hands, and they will not give you the 1 or 2 days time. Everything should be fast. You should be fast respond to the needs of the manager or the firms. So in this case, you should be good in using the softwares also, beside your knowledge. You need this knowledge. Why you solve it by hand in your exam and midterms? Because to learn the knowledge, to logic, how it's gonna work and what's the meaning of this. In order to make your process or work easier, you will use software, but at least you have the basic knowledge about the result of the software. At least when the result is came out from the software, you realize that what is it, and you can describe it to your manager, because they cannot understand what is the result of this software. So software using is a bonus for you, even to get a job for your future career. In this case, for this reason, in most of my course, I was trying my best to teach you some softwares related to that specific course in order to boost your skills for your future career. So for this reason, today we will start with this transportation and modeling from the optimization operation research one course. We will review together, because definitely it will be useful for you for your graduation project. So in the beginning, I just wanted to ask you actually about, do you remember why we need modeling, why we need formulation, why we do it in industrial engineering or even in any other engineering aspect or even the real life problems?
Doctor, to make the procedure more faster.
Actually, yes, but this is not the basic goal of this process. Why we make modeling? For example, let me make it a little clear for you to remember. You have a problem in your manufacturing assembly system. Maybe you have a lots of waiting time or you have lots of waste. You want to solve this problem. How you want to solve it? Yes, Mohammed, please.
By simplifying the processes, or like give sub projects to the main problem, like divide the problem by like little topics or little sub projects, something like that.
Yes, it's definitely right. Whatever you're telling me is right, but I'm just asking the main goal why we use formulation and we will use mathematical model. The answer is because if yes, Elvis, yes, please.
It's because you want to analyze the impact of a cost driver in the manufacturing process. For example, if the maintenance is actually impacting our production system, so we can analyze it to see how much it impact related to the cost, and it also related to the productivity of our system.
Yes, thank you. Actually, whatever you say is also true, but the main goal is because if we want to solve anything related to the real life problem, They are not something tangible. They are intangible. We cannot analyze them if we could not brought them into the mathematical model. This is the case. For example, for your problems, you need to define variables to merge to them in order to make an analyze on them, isn't it? Because, for example, how you want to realize that you have a waste or your waiting time in the assembly line makes a bottleneck? You should have a data first, and you should transfer this data to variables, yes, in order to work with it. For this reason, we are always using modeling or formulation to transfer the real life problems into mathematical models in order to find a solution for them. This is the case, actually. This is the main goal. And whatever you told all of you, of course, is true. But I ask you the base, the fundamental, the first goal. The first goal is this. So this modeling or mathematical model is not just related about industrial engineering, it's about any real life problems. You can model it and solve it with the mathematical models that you know, depends on the characteristic of the problem. We have lots of different methodologies. For linear, we have different methods. For non-linears, we have different methods. Integers, different methods. Non-linears, different methods. You know it. You had these methodologies in Operational Research 1 and 2. So we are just reviewing together. So now we just wanted to start the simple one, LP, linear programming. It is the simplest modeling for review. And after that, we will go for the transportation because it also belongs to the LP part, the transportation, it's Operation Research 1. So for this reason, actually, guys, I brought for you examples. Can you see my screen now?
Yes, doctor.
Yeah, if you remember it, this is a very famous examples from the Winston book, our reference book. We will just read it fast and then realize it how we can transfer these real life problems or I don't know anything need for solving this problem to the mathematical model. For example, this is a Giepo company. They are manufacturing two types of toys. One of them is soldiers and one of them is train. So we have some specific information about these two kinds of toys. So if you want to make each soldier, you can sell them, each of them, $27. But in order to do this, you should use $19 worth of raw material. Then increases Giappetto variables label overhead cost is $14 is given. It requires 2 hours of finishing labels and requires 1 hour of carpentry labels. This is the information for making a soldier toy. For a train toy, this is the information as follows. Sell for $21 and use 9 worth of raw materials. Increases Giappetto variable labels overhead cost by $10. It requires 1 hour of finishing labors and 1 hour of carpentry labor. Just for now, tell me what kinds of information that we have now. We have one information, for example, for the value of selling each of these toys. If you make a toy soldier and you sell it, it's $27, yes? And if you make a train and sell it, it's $21. But if you make a soldier, for making a one soldier toy, you need $19 raw materials. And for the train, you need $9 raw materials. Labor overhead cost for soldier is $14. For the train is $10. For soldier, it takes time 2 hours for the finishing task and 1 hour for carpentry task. For the train, for each of them, it's need 1 hour. So you see, this is a real life. We want to, for example, make it according to the mathematical models in order to write it down and find a solution. But this is just the information. So let's see what is the questions. Each week, this company can obtain the followings. All need raw material. It means there is no limitation for the raw materials. They have only 100 finishing hours and only 80 carpentry hours. Also, this is extra information, demand for the trains is unlimited and at most 40 soldiers are bought each week. So what's the case? Giaboto, this company, wants to maximize weekly profit, which is revenue deducted by expenses. Formulate the mathematical model of this company situation that can be used to maximize the weekly profit. So if you remember in our classes, always we were talking about the objective function. The modeling has three parts. First is objective function. You should define it. What is your objective function? Then your constraints. What is your limitations in sources, in time, in raw material, whatever, and non-negativity constraints. Yes? But before starting to write this model, you should define variable in order to transfer this real life problem into the mathematical model. So just tell me, for this example that we read together, how many variables we need actually?
Yes, Doctor, can we go back just to the slide before it?
Yes, of course, this is a slide before. So actually it's simple. How many toys we have?
Yeah, it's two, right?
Two, exactly.
Variables. We're gonna need two variables.
Exactly, Elvis. Thank you very much. So we will define it, for example, x1 for representing the soldier toy and x2, which means representing the train toy. So in this case, then we can start to write the model step by step. But first question, here it says that they want to maximize their weekly profit. So you remember that for the objective function, we have two types of model, minimization and maximization. Whenever we use minimization and whenever we use maximization, it depends on the problem. For example, if the problem is about a waste,
Minimizing.
Everybody wanted to minimize their waste. So if it's about profit, maximize it. If it's about waiting time, minimize it. So this is actually related to the nature of the problem. For this example here that we have, because it's maximal, because it's about profit, so definitely we realize that is a maximization problem. Of course, because for making one toy, you should pay for the raw materials. Here is written here revenue deducted by expenses, because that will give you the profit. So, step by step. As we talked about, first we will define the decision variables, which we have two. X1, number of soldiers produced each week, and X2 will represent the number of the trains produced each week. What is the objective function? Because it's a linear programming model, it's the simplest one. The decision makers want to maximize, which is usually comes for profit and revenue, or minimize costs. Always, we want to reduce our costs. Some functions of the decision variables. This function to maximize or minimize is called objective function that I told you just right now 1 minute ago. For this company problem, fixed costs do not depend upon the value of x1 and x2. This is our assumption actually. So according to this, we will start to write the model. You should remember it actually because we had it in Operation Research 1. So how we can write the objective function? So if you sell one soldier per week, per day, or per week, how can you write it? So x1 was represent of a number of the soldiers they can sold in a week. How much was the value of the soldier if you want to sell it? It was 27, yes? 27 multiplied x1. So x1 is unknown for us because we don't know right now how much soldier will be sold in the future. For this reason is like an unknown variable x1. X1 can be any value 1, 2, 3, 4, 5. For this reason this is a model. It can solve it for any kinds of amounts of production. Plus the second toy which is 21 x2 because the train value for selling it was 21. Yes? But this is everything? No, because if you remember for the profit, the revenue should be deducted by the expenses. What was the expenses? Raw material. For the soldier was 10 and for the train was 9, if you can see here. So 10x1 is the cost for the raw material for making a soldier toy, and 9x2 represent the raw material cost for the train, as much as we want to make 1, 2, 3, or blah blah, how many trains it will be needed. And also variable cost we had. So everything is a revenue should be deducted by the costs. For this example, we have two types of cost, material cost and variable cost. Again, for the first soldier toy is 14x1 and for the train toy is 10x2 because this information is given in the beginning. So now we can write the objective function. So the first one, which is all revenue, will be deducted by these two costs. And when we simplify them, we will reach to this 3x1 plus 2x2. Is it clear till now?
Yes,
Yes,
doctor.
doctor.
So this is the first step. We found the objective function. Now it's working for us. The second step, we should go for constraints. Before we go for the second slide, just tell me what kinds of constraints, how many category of constraints we have. Let me bring for you the real main. Yes, for example, yes, please ask me.
Doctor, it's
Doctor,
two
it's two
constants.
constants.
Yes, one of them is referred to finishing hours.
Finishing
One
hour
of
and
Our
carpentry
carpentry
hour.
hours.
carpentry hours, exactly. And we have also in one extra more constraints here because if you can realize or specify here, it says that at most 40 soldiers are bought each week. So this is an extra constraints for us. It says that. So according to this knowledge, we will go for write the constraint. So we realize that the objective function is maximization of z equal to 3x1 plus 2x2, which is so clear for us. For the constraints, the constraint 1 represents to the finishing hours. So because the soldier toy need 2 hour finishing and the train toy need just only 1 hour finishing, we will write it like this: 2x1 plus x2 less than equal 100 because it cannot exceed 100 because it's our limitation. And the second one for the carpentry, both of them were 1 hour. So it will be x1 plus x2 less or equal than 80. It cannot exceed 80 because this is our limitation. And the last sentences I told you before, it's about the at most 40 soldiers should be produced. We will write it here because x1 represents the soldier toy. It will be less or equal 40. So this is our also constraint. For example, here it says at most 40 soldier. At most, we will always show it with less equal. But if it was at least, this sign, it would be reverse. It would be x1 greater equal 40. But here it said at most. It means it cannot exceed more than 40. And as you can see, and this is our constraints. And after that, we write the constraints. What is the third one? Which we should always write at the end of the modeling process.
The region, like if x1 is positive or x2 is positive.
Exactly, non-negativity.
Non-negativity.
Always you should write it. Otherwise, your model will be not correct because we are always talking about the positive values, not the negatives values. For this reason, we will make the sign restriction. x1 and x2, they are also a positive value. So this is the final model. We had a very simple model. We wanted to maximize our profit. So this is the model. So according to whatever we produce, soldier toy or the train toy, this model will give us a new answer, a new z value. So this is actually what was the basic. Yes.
We can solve with the simplex then, right?
Definitely, yes, because it's a LP model. LP model can solve it by the simplex, but for now I don't want to solve it because we want to talk on just models, and after that how we can solve it with the software in a second session, because that is more important part for your graduation project. So this is it. This is the final model for this problem. It was so simple. This is the basic modeling, one of the basic modeling problems that we solved together. So till here, do you have any questions regarding to this example?
No, doctor, no, it's good.
No, doctor, it's good.
So, and you know that this is from where we can realize. For example, if you don't see the example, okay, you just see this model in your paper. From where you can realize that this is LP, linear programming, or NLP, nonlinear programming, or integer programming, just by appearance. First of all, answer my question. How many dimensions
It's about because like NLP has the general formula, but it's not like that.
NLP has what? Can you repeat it again?
Yeah, for the NLP, the constraints are like GI of X, it should be less or equal for BI.
Yes, this is mathematically yes. Yes, but I ask you, just imagine that you have a real model like this here, you can see in your paper, and it doesn't mention that by which method you can solve it. It just solve the following problems. Okay? Because most of the question for operation research is like this. You should define which kinds of methods you should use. First of all, you should define it, this is LP or this is NLP or integer programming by appearance. So first of all, number of the variables. Here is how much?
2.
2. It means that our problem is a two-dimensional problem. So for this reason, it shows that it's LP. And you cannot find any variables with the power more than 1. All of them are power 1. But if you see one of them, for example, here for the first constraint, realize it is 2x1 power 2 or plus x2 power 2. In this case, it's not a LP. It will become a nonlinear program. You will realize it from here. Or if you have more than two dimensional, more than two variables. For two variables is simple. You can also solve it with the graphical methods, if you remember. One time you will make the x1 0 to find x2, and one time give x2 0 to find x1. You can make it graphically, also you can find the best z, optimal z, and also you can solve it with the simplex method. So that was the case. And the other things, if this sign is written here, x1 is integer, so you're realizing that this problem is not a LP or not an NLP, it's an integer programming, and you should follow the integer programming methods. But here, because both of them are positive, greater equal, so it's the simplest one. So this was the basic fundamental principles of the modeling, if you remember. But now I wanted to just prepare you for this part because most of you wanted to use transportation model in some part of your graduation project and solve it with the Lingo application. Now I also prepared for you an example to remember and review together about the transportation problem. So till here, you don't have any question. If you have asked, then we will go for transportation.
That's good.
Thank you very much.
No question, doctor.
Thank you very much. So I will close this example. We will go for example for transportation. So in transportation model, the system situation will be different, guys. What is the difference between transportation and this modeling that we had before in just 1 minute before? What is the difference between them?
It's first the number of variables.
And another one?
And the objective function, it will be minimizing, I think.
Yes, of course, because always we wanted to minimize the transport. And one point before we want to start the main point, I want to just tell you many important things. You are in the last years, you are in the last semesters, most of you. Graduation project is your course. Whenever you look to any problems, I always told you in the class, you should look at it from top to down. Yes? So, because now you have a wide knowledge about all industrial courses, and now most of you came to me and tell me, they are so similar. Yes, actually, all of them they say the same thing, but from different side of views. And now this is your art to how can connect and merge this knowledge to solve your own problems for your specific firms or anything else. So always you should look from top to down to the problem. So from the top part in our courses, what is it? We're always, I ask you in the questions now, what is our main goal in industrial engineering?
Sorry, can you repeat the question, doctor?
I ask what is the main goal of to be an industrial engineering? What they expected from us to do in a company?
We have to reduce waste and gain more time and make the procedure more faster.
Yes, and Elvis?
Reduce waste like Tariq said, and also reduce cost.
And Muhammad, please, you can also say your opinion.
To find the optimal solution for any problem.
That's it. This everything everybody said it was true, but this is generalized actually.
We can say optimize.
Exactly. Optimizing everything. Optimizing your process, your waste, your waiting time, whatever it is. So optimizing This is our first duty. And related to that, what is important tools for us or important knowledge that we are following? It's lean thinking actually. Lean thinking is like a mother, and all these branches that we learn in these different courses is returned back to that one because this is the main goal. This is the first goal to increase the customer satisfaction. It means that if you can reduce your waste, if you can reduce your waiting time, if you can reduce costs, if you can increase the delivery time to your customer, in this case, directly and indirectly, you are beneficial for your company and for the customers. You will reach to two purposes at the same time. So because the customers want to get the service fast as soon as possible with the lowest cost and best reasonable quality. If you can do it, the satisfaction for the customer will increase. And at the same time, your cost is reduced, your efficiency is increased, and blah, blah, blah. So this is the goal that we are doing. Transportation is one of them. If you remember from the lean thinking course, yes, Muhammad, ask me please.
Yes, doctor.
Yes, doctor.
Sorry,
Sorry,
I
I
just need to
just
tell
need
you
to tell
that
you that
I'm gonna
I'm
leave
gonna
because
leave
I have
because I
an
have an
appointment
appointment
after
after
30 minutes.
30 minutes. It's fine, it's fine. Thank you very much.
Sorry.
Sorry. Thank you very much.
Thank you,
Thank
doctor.
you, doctor. You are welcome. So, in this case, I just wanted to know if you remember the waste, 8 waste in lean thinking. You remember it was Tim Woods. The first T is related to the transportation. Yes? So transportation in our logic, in a lean thinking logic, is a waste. So you should always try to minimize. The other waste was I was inventory, M was the motion, it means the movements of the workers between the devices and machines. W is the waiting time. O, the first O is over process, over product, the second O. D means defects. It means always you are trying to minimize your defect. And the S for Tim Woods, S is unskilled worker because if you have also the unskilled worker, it will affect your efficiency and your manufacturing process. So transportation that we are talking now is just one of these problems and one of these ways that we want to reduce it. For this reason, we will just always, as Bakir said before he leave, he said that it's because we wanted to minimize the transportation distances. Because if you reduce the transportation distances, indirectly you will reduce your fuel consumption and also delivery time will be reduced actually. So it has many direct and indirect benefits. So as we talked here, for example, the case is if you want to solve the transportation problem because you are moving from this point, because it's transportation, you are moving from this point to the next point or from this stage to the next stage. So in this case, defining decision variables is a little different. Yes? Is not just only x1, x2, or xi. Because in this case, we cannot represent it. How we should deal with it, dear Elvis?
Sorry, doctor, can you come again?
How we can define the decision variable for transportation problem to start write the model. Because it's moving from this point to the next point. So you cannot just define xi or x1, x2. It's not going to work for us. Because it's 2 points. We want to go from this point to the next point. So in this case, we need to define a variable with 2 indices. If you remember. Yeah, x, I, j. It means you will go from point I to the point J. You will write. So this is the variable for transportation problem, xij, because we are moving between these 2 points. That's the reason we have here such a thing, as you can see. So imagine that we have here is a very simple example. We have 2 stone mines supply their road construction with stone. The production of the mine is in 1,000,000 tons is 7 and 12 respectively for the first mine and second mine. The quantities required by the road constructions are 5, 6, and 8. The unit cost of the transportation are the following. So the table is given. What's the question? Give the linear programming model of the problem. So it's obvious that this is a transportation problem because it's also mentioned here for us. And in transportation problems, if you remember, the numbers in the table, they're always the costs. Yes? How many mines we had? It said we have 2 mines. So the first row actually represents the mines 1, and the second row, it will represent the mines 2. How many roads we have? It says 5, 6, and 8. So we realize that these columns are the representative of the roads. Roads 1, road 2, and road 3. Each of these mines, they have a limitation as a constraint for us. The first mine, maximum they can supply us by 7,000,000 tons, and the second mine can cover us with the maximum 12,000,000 points. Yes? So how we will write this construction? But before that, in the transportation problem, before you want to start to solve the problem, you should check one thing. You should make a summations of row and columns, and they must be equal. If they are equal, we say a transportation problem is a balance problem. Yes, you remember? And if it's not equal, we say the transportation is an unbalanced problem. And by the way, tell me, if the problem is balanced, so it's easy to deal with it. You will start to write the model. But if it's unbalanced, what we did before in our classes for this, to solve this phenomenon, do you remember? Yes, dear.
Can you repeat the question, please?
Yeah, I said if the transportation problem is unbalanced, how we can fix this issue? By defining the dummy variable. You remember? This dummy, it could be in your minds for this problem or the roads. Anywhere. To just make them balance. Hello, by the way, this is what's just a question I wanted to ask you. But these questions, if you see here, the summations of the rows, which is represent to the mines, is 19, is equal to the total of the demands of this construction road is 19. So this is a balanced model. So in this case, it's easier for us. So how we will write the constraints here? Very simple. So this constraints is for the capacity of the mines. So mine number 1, the capacity was 7. Yes, because it's mentioned here. How we will write it? How we write this? What is the meaning of this? x11, x12, x13 is equal to 7. What does it mean? x11, it means that if you want to take your raw materials from the mine number 1 for the road construction 1, This is 1, 1. It will be 3 actually for you. For per each stone or kilogram or ton, whatever it is. Each of them is 3. It can be dollar or anything. X12, it means if you want to supply your raw material from the first mine to the second road construction, so it will be X12, that we wrote it here, and for the third one is X13. Okay, if you want to take your raw material from the first mine for the 3 road construction, it should be equal to 7 because the mine 1 maximum capacity is 7 million ton. It cannot give you more stones that you need. And the second line is for the second mine. If you want to take your raw materials for these 3 road from the second mine, so you will write it exactly like this: 2, 1, 2, 2, and 2, 3. It should not be more than 12 because the limitation for the second mine is 12. Is it clear?
Yes, Doctor.
Yes, doctor.
So you remember that for the transportation model, we had 2 types of or 2 category of constraints. One constraint represents the demand and the other one represents the capacity. So the things that we just talked about it right now, it was about the capacity of the mines. Yes, because these mines, this is their maximum capacity. So the first part is done. We wrote the capacity constraints for the model. Then we should go for the demands. Where is the demands? Demands in on the roads. Roads 1 has 5 million ton, road 2 6, and road 3 8 million ton. This is their demand. So for the demands, conversely, we will go columnar, column by column. So for the first row, first we should write it for the first row. So capacity was 2 because we had just only 2 mine, but for the demand, how much it will be, how many demands constraints we will have?
Doctor, we have 3.
3, exactly. So as you can see here, so for the first road, we will write it as same like before, but I told you for the demands, we will go columnars because, for example, this 5, 6, 8 is actually should written under this table. For the first road is 5, then 6, then 8. So then how we will write it? We will go columnar. So x1, 1 plus x2, 1, it should be 5. It's here written. Then x1, 2, x2, 2, it should be 6. And x1, 3, and x2, 3, it will be equal to 8 is given here. So actually right now even we write the demand constraints for the transportation model. Yes? So what is remain here now? What we should write now? We just wrote the constraints.
Like we have to write the subject to. No, I'm not sure.
We should write the objective function.
Objective function.
Objective function.
Exactly. So for
I
objective
wanted to say
function,
it, but
yes. Thank you very much. Yes, that's correct. So objective function for transportation model should be minimum or maximum?
minimum.
Minimum. We just talked about it. So it will be minimum. And in order to write the objective function, how we will write it and which kinds of information we should use? So because it's minimizing the cost. Where is your cost? Cost is here in your table. It says the unit cost of transportation. It means that if you want to move, for example, 1 million ton from the mine one to the road one, each ton is 3 million, for example, or $300, for example, is the cost of it. So whatever it is. So how we will write them? They are the costs. So we will write it so simple. These costs should be multiplied to the amount that we want to carry from the mine number one to the road number one or two or three. Yes? So how we will write it? Just please tell me the first two and then we will see the result. So I want to start it. I want to start it with the mine one and road one. Here, number three. How can I write it?
You write
You
like
write like
x11
x11
and
and yeah.
x12.
x12? Yes, but what about these numbers? Costs. Costs should be multiplied because we don't know
Multiplied.
how much it x11 will be. Exactly. So it will be 3x11 plus 4x
For
4
x12,
x12 1 2 plus 5
x13.
x13 x13 exactly plus 7. Now we can see the result plus 7x21 plus 6x22 and 8x23 exactly. And at the end don't forget to write the non-negativity constraints exactly here, because you see the decision variable for the transportation problem is xij. It will be greater equal 0. It means it's always that 0 and a positive number. So this was actually the fundamentals of the formulations of the simple models. LP and transportation model is also is the LP model. But the case is in transportation, the constraint size is always equality. When is equal, when we will write it equal, when is the problem is balance, which means that the summation of the rows and columns, as you can see here, the capacity and the demands are equal. Yes? Otherwise, otherwise, how it will be the signs? The capacities will be less or equal because capacity is in your hand. You know how much you can produce. For this reason, it's impossible to get more than that. So it's always show it with less or equal. It is unbalanced. And for the demand, you should write it with greater equal because the demand is the thing is not in your hand. Maybe it will increase or maybe it will decrease. For this reason, it will be greater equal. So this is the difference between the balance and unbalanced transportation problems. So that's it. I hope this review help you to review and remind you about these important notes when you want to use it for your graduation project, this model. This is a very good revision for us together. And after that, in the next second session of a transportation and modeling part, we will talk about the how to use these models in transport in a software, Lingo software. If you remember that you had it before, we will again review it together. We will use this software to solve such a problems, because in your graduation project you don't need to solve it by your hand because it's a very big model. This is for the company you brought it from, your internship company or other companies. It's not as simple that you can solve it with your hands. So you can use the Lingo software to easily you can solve your model and just have the result. And based on the result, you can describe and give the hints what you should do, what is this case, and you can describe and have a conclusion from that result from the software and write it in your graduation project report actually. You can just discuss it actually. Instead of solving, you will discuss the result that you get from the Lingo software. So for now, if you have any questions from this part that we talked, you can ask me. Otherwise, the first session is finished, and the next one we will make it after a break. We will use these models, use the Lingo software to solve these models together. Any questions?
No questions.
Thank you so much, doctor.
You are
It's all
welcome.
clear.
Thank you very much. I hope you enjoyed it. And so we will just make a break. And after that, we will discuss these same things, these models in the applicable part, in the application Lingo software. Thank you very much and have a good day for now.